So welcome back everybody. So very happy to introduce our second quantum computing session of the day. I hope you're all refreshed from the lunch break back, had some coffee. Before we start, I would like to ask all of you who are preparing a poster, or who did prepare a poster, to take your poster to FEMIS at the registration, so FEMIS can take care on putting the poster to the poster session downstairs already. And it would be good that all the posters would be there at least on Wednesday evening, so that FEMIS can prepare for the next day. So now I have the pleasure to introduce Michael Falkenthal, who will give the next talk. And it's a talk on PlanQ, a project we've heard now a few times already during the other talks. And Michael Falkenthal is a former colleague from University Stuttgart who worked 5 years on formal aspects on patterns. And Michael Falkenthal is now 2 years at StoneOne, so he changed to industry and is there head of tech for quantum computing and AI, and this is why he's going to present our PlanQ project. So please.
Thank you, Anna, for the introduction, and maybe let me start with a short story how I stumbled into this whole PlanQ and quantum computing stuff, because it was just before Christmas in 2017 when at that time I stepped into Frank's office and he asked me, well, Michael, are you interested in quantum computing? I said, well, sounds interesting. When are you going to start with it? Well, yes, you know, at Christmas I have always time to work. So therefore I went back home, told my wife I have to cancel the vacation, etc. And then of course I went past Christmas then to Frank's office, and we started then with all the background and fundamentals of quantum computing. And yes, this was actually my introduction to quantum computing, which then finally led also to this nice project called PlanQ, which I will introduce to you. And as you can see, the ring is still there, so also at home everything worked out. So PlanQ. I think the largest quantum computing, quantum software project, as far as we know in the Western Hemisphere, funded by the Federal Ministry for Economic Affairs. And as you can see here, yes, at first it was very close to AI, artificial intelligence, because we had to do some tricks, etc., to get the funding. But now finally, at the moment we are renaming PlanQ. PlanQ stood for Platform and Ecosystem for Quantum-Assisted Artificial Intelligence. But as we have heard by Frank this morning, we learned a lot, and therefore now PlanQ is all about this part here, quantum applications. How to develop quantum applications, how to incorporate quantum algorithms, etc. All this nice integration stuff, which was already mentioned by Frank this morning. So let's have a look what was and what is still the current state in the whole ecosystem of quantum computing. As you can see here, we have different stakeholders, of course, but unfortunately they are kind of loosely coupled until today. So we have industrial users, early industrial users, of course, front runners interested in new technologies like quantum. We have the researchers on the other part, not talking to each other. Of course, in conferences like this one, we have many attendees also from the industry. This kind of connection gets established more and more, but still not a very good connection at the moment to help especially the industrial users with their problems at hand. We have the hardware providers like IBM, still doing research stuff, how to build quantum computers, how to make them more useful, etc. for real use cases. We have the quantum developers, today mainly quantum physicists, as Frank also mentioned. It's not so easy for computer scientists not having the background in quantum physics to just start over and write new algorithms, quantum algorithms. And so one of the main ideas of PlanQ was, well, we have to bring all these stakeholders somehow together, to work together, because each and every participant cannot work on its own to establish this new technology and bring it to real use cases in the wild. Yeah? And therefore, the vision from this stakeholder perspective of Planck, of course, was to bring all them together. In the center is this nice Planck logo, and of course, as I will show you also later on in this talk, I will give you a glimpse of a demonstration of the platform. This is not just a project, but it is also a whole platform, as stated in the title, of course. Yeah. And Planck also consists of many partners. I mentioned largest quantum software project as of our knowledge of today, and we have the core consortium on the one hand, 20 partners from industry, from academia, and also like bridging institutes like Fraunhofer institutes, etc., bringing, let's say, innovations from science also to the industry. And of course, we have also many associated partners. So when we try to convince the federal ministry to have this project, we went out and asked also additional partners if they would be interested in this kind of project and also this kind of platform. And yeah, the response was great. So we have over 80 associate partners just waiting to get access to the platform, to play around with quantum stuff as of today. And the number is increasing almost daily. Yeah. And to give you, let's say, a quick overview on what Planck as a platform is about, I brought here this very coarse-grained architecture view of the Planck platform. So mainly it is distributed into two aspects, so to say. On the one hand, we have an analysis and development platform for algorithms and all stuff around algorithms, also like data to evaluate quantum algorithms, this kind of quantum applications, which we have heard this morning about, and of course also this workflow stuff, which was introduced by Benjamin this morning. Yeah? And let me start here on the left side. What makes this Planck platform, let's say, special in a way? What's the core to establish this whole ecosystem and to bring all the stakeholders together? So let's start on the left side. We have something which we call data content store, or let's call it each and every quantum paper introducing new algorithms can be scanned with a nice open source tool developed by the University of Stuttgart. So we scan the archive, this whole libraries and registries of papers to find new developed stuff, which is then interesting for this whole community. And of course, we have many researchers also in the project coming exactly from that background, and those guys read those papers, of course, if not written by themselves, and yes, normalize the input somehow. I will show you later on how we structure this whole quantum knowledge into so-called knowledge artifacts on the platform. And the first one is, of course, just a description, just in quotes, of quantum algorithms. But it is a description in a way that a user of the platform can get very quickly into the core concepts of the algorithm. And also, I think there was a question this morning, where can I find the explanations? Why did somebody do something? Yeah? And this is also part of this knowledge base. And of course, we don't stop by just the mathematics and the descriptions of the algorithms. We have also here in this algorithm repository implementations of all these algorithms. So we enrich the descriptions, the concepts, with also exemplary implementations. Some of them done in Qiskit, in different SDKs, and also vendor-specific SDKs, so that one can get into the whole knowledge base, find an algorithm interesting to solve a problem at hand, but then he or she can also navigate even further to implementations and play around with them. And of course, this morning we have also heard about quantum patterns. We have learned lots of stuff about how to build applications and also quantum algorithms. So the essence, as Johanna described this morning, is then also captured in a quantum computing pattern repository, which you will also see later on. And of course, I mentioned there's It's not only because in the first steps the project was about AI. It's also important to evaluate the quantum algorithms to have example data, so that you can just take an algorithm and just run it, and then play around with some with some settings, play around with data, etc., and to get a better understanding how an actual algorithm works and how sensitive it is to some changes, etc. And finally, of course, we have also this kind of application repository. I think Frank mentioned it as a marketplace somehow, where you can also download and use whole quantum applications. So not just the little chunks, the algorithms, but the algorithms embedded into whole applications, which you can then also download and provision on demand with the Open Tosca ecosystem. And this should also look very familiar to you, because many of those components were already also introduced this morning by Benjamin. We have also figured out this thing Frank mentioned, quantum applications are always hybrid, and therefore it's an integration task. And well, we did integration of services for a couple of years now, and therefore you will find here also this components about quantum workflows. So tool support to grab services, quantum services, and glue them together to make even, let's call them, larger, more valuable services out of it, or to tailor some services, quantum algorithms to some specific use cases at hand. And on the right side, now leaving the more or less the research part of the whole project, we have also a marketplace, and the idea of the marketplace is simply, well, there's so much knowledge produced in terms of algorithms, that they can be, let's say, provided as services on the platform, that it would be a shame to not make them valuable products in itself. And this is of course what's done in the marketplace. So I think just in a glimpse, therefore the whole platform consists now of some core components and functionality. This whole concept of the knowledge platform, which I described, the marketplace, which I described, data rooms, not just files, but whole data rooms where you can share data with different participants. The NIST analyzer, which I will point to Marie in the next talk, which is a nice component to evaluate code and to figure out if I have an algorithm, then the question arises, well, on which quantum backend can I execute it actually, etc. So some tool support to actually develop and tailor algorithms to backends. Yeah? The workflow stuff already mentioned by and described, the provenance stuff, the patterns, and the quantum application packages, as also introduced by Frank as self-contained packages, including everything one requires to provision an actual quantum application. So, but Planck is not just the development of this platform in its core. The platform itself is also constantly evaluated and validated by the use case partners in the project. And currently we have more than 30 use cases that are, so the partners play around with their problems at hand to figure out how far we are today with quantum hardware and quantum algorithms, how far we can go with problem sizes in these specific domains. And of course, for doing that, they use the Planck platform, and therefore we constantly generate feedback from them and tailor, therefore, also the platform from day one to the actual needs of the use case partners. Use case partners doesn't mean necessarily just industry partners. We also have, of course, research partners playing around with quantum stuff, etc. So from all the different stakeholders, we have, let's call it a feedback loop that constantly feeds us with new ideas and feedbacks, etc. And I've brought a little example with me where we also work on, because today we have heard about workflows, we have heard about quantum applications, etc. But as of today, we have even, let's call it a simpler problem to overcome. And this is, well, today algorithms are developed mainly in, let's call it Jupyter notebooks. Many of you know that, etc. And they reside typically on the local machines or in some Git repositories. And Frank mentioned, say, the new way of thinking is APIs have value, not just open source, which lays somewhere around and nobody uses it. Yeah? And therefore, we also developed you could say a serverless platform with APification capabilities for quantum algorithms. Yeah? So we try with the platform, we try to bridge this situation where we have the code snippets laying around, nobody can use them, to raise them to actual products, which are then consumable services on the Planck platform, which then can be brought into all this orchestration stuff, which was introduced already by Benjamin this morning. Yeah? So the service platform takes code snippets. You have to develop them by some convenience, so to say, and then the platform can consume it. And the code snippets can wrap it with an HTTP API completely automatically. It containerizes everything and deploys it to technically it's a Kubernetes cluster, of course, but it deploys it somewhere. This is not, we don't stick to Kubernetes, it's just what was just a convenient way to accomplish it. And of course, what we do here is, we have this typical situation that the developers are quantum scientists currently of the algorithms. So, to be honest, they have no clue how to bring software to production. Yeah? And this is also what the Planck platform currently already does. So, and now I want to show you also a quick demonstration of the whole platform and how it looks as of today. So, let's go full screen. So as you can see here, everything is, let's say, structured first of all in two different parts. We have the service platform, which I mentioned some seconds ago, and we have this community platform stuff. This is this research part. This is where all these algorithms are described, where the algorithm knowledge is shared, where the algorithm implementations can be shared, etc. And if you have a closer look, the project did already lots of stuff about quantum algorithms. So if you're interested in some algorithm, once the platform is open for everybody to sign up, then you can dive into here descriptions of the algorithms. And just to give you an example, we also took our conceptual thoughts, which are the basis of patterns, design patterns, into the description, into the structures, into the canonical form of algorithm descriptions. So you see, Johanna has introduced it this morning. We also provide a specific form how to provide the knowledge artifacts on the platform, because we wanted to overcome the situation. Of course, you could argue you can also find this information in the original papers. Yes, of course. But the idea here is that we take this initial information from the papers and put it into a structure which is then easily understandable for the users. And therefore, we always start with an intent, a short summary, what an algorithm does. Then there is a problem description. Then there comes a solution. And in this case, it's a larger section. Yeah. Then we also describe what are the formats, how has the data look like to be consumed by the algorithm and processed by the algorithm. Which hyperparameters does an algorithm have? How can I adjust things, the processing of an algorithm? What's the output of an algorithm, etc. And you will find in each and every description of an algorithm on the platform exactly this structure. And as you can see here, we also link the knowledge artifacts, the algorithms in description with each other. Because the idea is not to just, make out isolated chunks of knowledge in this whole knowledge base, but to link all this knowledge so that one can also figure out, well, if I'm interested in this specific algorithm, well, then also other algorithms might be of interest for me. And of course, as I mentioned, you can also navigate here to the implementations of this specific algorithm, and that's here it's the same play again. We have specific sections to describe implementations, and of course these sections allow to specify, let's say, the circumstances of this implementation a bit more, because even you could say, well, it's just an implementation of an algorithm, but typically implementations come with further constraints, and these further constraints that apply for a certain implementation can be put in here. And of course, a description for the users, how to actually run this example implementation. We are not stick to some format, so you could provide here, like in this case, just a zip archive. You could also provide Jupyter notebooks, so whatever you want. So, and finally, the last aspect I wanted to show to you, we also have here this pattern atlas introduced by Johanna this morning, and of course you can also find these quantum computing patterns which are currently available on this page. And I think there's also a link here to the quantum computing patterns as stated in the presentation by Johanna. So you see, we get together knowledge about algorithms, we get together, we bring, but we also bring knowledge about how to create algorithms and also how to, let's say, integrate stuff to actually build quantum applications. I think this last part is still lagging a bit, so I guess there will be many more patterns in the future. And I have seen this nice picture by Johanna this morning, structuring all the patterns, and looks promising. Yeah. So, okay, and I want to show you in the last couple of minutes of this presentation this apification stuff. Yeah, because we have a lot about the Tosca, the QAI application stuff with Tosca by Benjamin. We heard a lot about the workflow stuff, but now the question is, well, if we want to integrate something, especially services, so to say, yeah, well, where do the services stem from? And I will give you a quick demonstration how you can very easily put your, let's say, algorithm codes and throw it on the platform, and the platform does the rest. First of all, that you don't have to write the code on your own. We have a code scaffolding tool developed, and this provides you with the structure, so where you can develop into. So, for instance, if this is some of you may know QMan. This is a code scaffolding tool written for the NPN ecosystem, and if you just execute this command, you get this generator, and then you can say, well, I want to work with the latest version of the Planck platform, so go ahead. Do I want to develop in Git or no? I stick with no at the moment. And what's going on here is that, let me open it, that we scaffold a whole project for you. Yeah? So you have here a whole structure, and you don't have to begin on a white paper. So if you want to develop an actual quantum algorithm which is consumed by the Planck platform and be executed on the Planck platform and wrapped as a service, etc., you do this scaffolding, and you have this run method, and here the story begins. This is the default entry point, and all the logic starts here. And then, algorithms are today to be developed in Python. You can put your whole Python project in there with this entry point. So, based on this, you can then also go to the platform, and once you're done with the implementation, you can say, well, I want to raise this implementation now to a service. Yeah? And therefore, you can go to the Create Service tab. You can say, well, I zip everything, what I coded, and you can just use this and upload it. You can specify then the API with an open API specification file to the service. You can provide here some neat descriptions for the marketplace. You can select on which quantum backend this service should have access to, and of course you can also add pricing plans to monetize actually your actual service. Let's go here for, let's say, you have to pay per month 1,000 euro when you want to use it. And then you can click on create service. And everything what you see, of course, can also be integrated in the CI/CD pipeline of your own, so that the Planck platform can be the logical, let's say, endpoint for quantum services, for deploying quantum services in the wild. And of course, now what the system does, it takes this developed code, wraps it with an HTTP API based on the Open API spec file. It containerizes it, and then of course it deploys it as an endpoint. And to save a bit of time, of course, I've prepared this kind of service already. And as you can see here, you can just unpublish it in a second. So let's imagine now you have created the service, and now you have two possibilities. Yeah. On the one hand, you can put it to the marketplace, which is actually the public place. Then really customers can visit the Planck platform, the marketplace of the Planck platform, and yes, subscribe for real money to the service. Or you can, today we are creating services for development purposes. Then of course you can also go with internal publishing, which means then it is available for all the members of your organization. Yeah. But now I have published it to the marketplace, and if we now go to the marketplace, you see it loads that the SummerSOC prep published by myself here is now in the actual marketplace. And of course, to get access to this implementation or to this service, you can also create a so-called application on the platform, which provides you with credentials that can be used then in actual applications, so that they can then authenticate against the Planck platform and send actual requests to the service. Yeah. And because my time is running out a bit, I think I will stop the demonstration here, because I'm most important. Some final words about the sustainability. So often it is the case in projects, well, once the project ends, all the nice ideas are gone. And currently, I was introduced being a member of StoneOne. Currently we are building a new product unit called Nanocore Frictionless Quantum, because what we have in mind is bring all these ideas together, and also to host and provide the Planck platform also far beyond the Planck project. And currently we are preparing to open this whole system in the open beta, and this will be the case in the second half of the year. So everybody of you interested in the Planck platform, here you can key in apply for beta.planck.de, or just scan this QR code, or meet me at my poster on Thursday. Then we can even go into more details about the Planck platform. Thank you.
Thank you very much. So are there any questions? You all want to work with the platform? No questions left?
So at least in machine learning, like when people build app with the Python and Jupyter, etc., they use, okay, not everybody, but a lot of people went to C and then rewrote the app again and deploy it. Like, would that also happen, or would you see that mainly it will run on Python? Or
ja.
Currently we see like almost all developments are done in Python currently. So this is the whole stream, quantum development, etc., comes from data science, etc., and therefore Python is currently the way to go. Of course, there are new developments, for instance, in the Qiskit SDK by IBM. They also go for Rust as a more performant programming language. but mainly in the let's say in the background in the compiled classes, etc. So, but the main interface with user code, so to say, is definitely Python at the moment on the algorithm layer. Yeah.
I think what I mean is that initial development and until you figure out the algorithm, Python is there. But when you know this is what we want in production, I think then maybe it's okay to say, okay, pay like write real C program and get it done, etc. Maybe an option. So yeah, definitely.
So any other questions? Now it works again. Otherwise, I would say thank you very much, and we're perfect in time. So. And I have the pleasure now to introduce a current colleague. So it was a former